Hello, my name is Dr. Vlad Krotov. I'm an Associate Professor of Information Systems at Murray State University. Welcome to my video lecture on information systems. As you can see from this diagram, the concept of information systems is central to the field, to the major, and to the profession of CIS, Computer Information Systems. And that's why we'll spend quite a bit of time discussing what information systems are, what are the most important components of information systems, where this concept came from, and we will also go through some examples of information systems in the workplace. More specifically, upon completing this lesson, you should be able to discuss the impact of information and communication technologies on business and society, discuss what information technology is, explain the difference between data, information, and knowledge, define systems, explain system thinking or the so-called socio-technical approach to information systems. You should also be able to explain what information systems are and discuss components of socio-technical systems. Finally, you should be able to explain the difference between the fields of MIS and CIS and also discuss some examples of computer information systems, management information systems, and also enterprise systems. So these are the learning outcomes for this video lesson. Today, IT, or which is the same term, information and communication technologies, are pervasive and have a profound impact on individuals, organizations, countries, and the world as a whole. To get a better sense of what kind of impact information and communication technologies have on individuals, organizations, countries, and the entire human civilization, I suggest you watch the following video, Did You Know, from 2019. I think this video has been around for about 10 years. Every year it gets updated, either by the original author or somebody else. So what this video does in 5 minutes, it lists some of the most important trends that are impacting different countries and the entire human civilization. And as you watch this video, you will see that at least 50% of those trends are related to technology. Not everything is related to technology, but a good 50% has to do with social media, the development of the internet, the development of artificial intelligence and things like that. So please pause this video and go to YouTube to watch Did You Know 2019 video. So after watching this video, you should probably come to the following conclusion. Nowadays, there's no escape from information technology. Maybe 10, 20 years ago, you could have said, well, I'm not good at computers. I don't like computers. I want to stay away from computers. I want to stay away from IT. Therefore, I don't know, I will be an elementary school teacher. But you know that nowadays, even elementary school teachers, they heavily rely on various IT tools to deliver their lessons, to monitor progress of their children and things like that. Even farming, I mean, for a number of years, farming was used as an example of a very low-tech industry. Again, an industry where you can afford not to have information technology. But nowadays, it has changed. Even farming is becoming a highly digitalized, highly automated field. So no matter what kind of career choice you choose for yourself, most likely you will end up using information communication technologies heavily. So let's start with the definition of the taxonomy that explains what information technology is, or IT. When people say IT, they typically mean three things: software, hardware, and data. So one example of software is Microsoft Excel sheet. When they say hardware, it's pretty much anything, starting from a CPU unit, RAM, and all the way down to networking equipment such as wires or routers. Okay. When we talk about data, we're talking about those little tiny bits of information that is coming our way. Typically, when they say data, they're talking about digital data. It's not just any kind of data. So this is what they mean by information technology: software, hardware, and data. Now, of course, there are many subcategories within each of those main categories under the umbrella of IT. For example, software can be application software, meaning the software designed to accomplish a particular task. For example, Microsoft Word, Google Chrome, they can be classified as application software that helps us compose documents or browse the web. Then there's system software, something that supports the overall system, computer system, helps running it, such as Windows operating system, iOS operating system, Android operating system. And then we also have utility software, something that supports our work with the system, such function as archiving or backing up your data. When it comes to hardware nowadays, there's all kind there are all kinds of devices out there. So probably these are the main categories: end user computing devices such as desktop computers, laptops, mobile devices such as smartphones. I think mobile devices now, I mean, they've been around for I would say for the last 15 years, as a popular platform for end user computing, and nowadays they're as important as ever. In fact, everybody expects everything, all IT resources, all data, all information to be available through a cell phone, be it a learning management system or an enterprise system. So mobile devices is probably the most dominant end user computing platform. And then you have networking equipment, something along the lines of servers, routers, and firewalls. Firewall can be software. It can also be like a physical box equipped with software. So those are classifications for software and hardware elements of information technology. Now, the difference between data, information, knowledge requires us to become a bit philosophical, but I'll use some practical examples to make it less esoteric and hopefully more useful for everyday application. When we say data, we mean raw facts. Just think about some kind of system that is streaming, zeros and ones, or like words. For example, just imagine somebody working as a cashier, as a point of sale cashier at Walmart, and this person keeps scanning all those items that are purchased by customers. So each item is being scanned, and then this information about this item being sold, let's say with the code, the name of the item and price, is being streamed in real time, through the network. So that will be data, data about sales. Okay. Now the concept of data has been around for a while. For example, if you took courses in accounting, there's something called general ledger in accounting. In the old days, general ledger was a physical book like this one, and this is where all accounting information is entered. All transactions are entered. So whenever there's any kind of transaction, let's say you sell a bottle of Coke, you enter that transaction there. Okay. So this is data, just routine transactions that happen every time when you sell something, when somebody gives you money, when you give money to somebody. So this is all like data. Okay. This data itself on its own, so if somebody's streaming data or just gives you like a huge general ledger, it's not very useful because it's raw. I mean, it's like a raw resource. It's disorganized. You cannot make much sense of it. Right? You just see all those transactions, but you don't understand what it all means. Okay. Now, when you take those transactions and you aggregate them together, and in accounting classes they teach you how to do that, you have information. So information is processed or summarized data or summarized raw facts that can actually be useful in decision making. Okay. So for example, if this is a general ledger for Wachovia National Bank, then based on all those transactions, we can compose the so-called balance sheet. Right? So this looks like a balance sheet with assets, liabilities, and shareholders' equity. Okay. Again, if you took accounting courses, you know that a balance sheet is a snapshot of company's position at a particular point of time. So here we see how much the company owns and also how much the company owes. So we see the overall financial health of this organization through the balance sheet. Okay. So this is information. So what kind of decisions can be made based on this information? Well, for example, banks, they use balance sheets, and insurance companies, they use balance sheet to determine somebody's credit worthiness, right? So if company has quite a bit of assets and those assets are less than liabilities, then they will say, well, okay, this company seems to be in a good financial health, we'll give them money, right? So the unfortunate fact of life is that banks like to give money to people who don't need money, right? And if you do really need money, if you're desperate, if you're in a bad financial situation, they don't want to give you money because they will look at your balance sheet and you will see that you have a lot of debt and unfortunately, and not too many assets, and they don't like to lend money to people like that. So this is information. So you can make a decision whether somebody should be giving out a loan or not based on information. You cannot really make this decision based on a general ledger because there are just too many transactions. It's hard to make sense of all of that. Okay. And now there's a third level of distinction, something called knowledge. Okay. Now, information is one level above data, and knowledge is one level above information. So knowledge means being able to actually do something, do something valuable with information. Okay. Now we're getting a bit esoteric and philosophical, but for a long time it has been argued that information systems, they equip us with information. But this is not enough. I mean, having information is not enough. You need to be able to do something useful with that information in real life, right? For example, Warren Buffett, I mean, that's what he has been doing most of his life. He's been looking at financial statements of companies, looking at their income statements, balance sheets, and cash flow statements to decide whether to invest his money or not. Now, I think Warren Buffett, he likes to shock people with some eccentric rumors or eccentric pieces of information about himself. But, you know, for many years, he has been claiming that he doesn't own a computer, that on his office desk, he doesn't have anything except a calculator, and then everything else is being brought to him by his secretary, like in printed form. So basically, he sits in his desk and has a bunch of printed financial statements that he ponders over to decide in which company to invest money. So what I'm trying to say is that knowledge is the ultimate goal of information systems. I mean, if you have like a very powerful information system, but it doesn't give you that knowledge, that power to make wise investments, then it's of little use. Okay. So, and apparently, if somebody has knowledge, then he or she doesn't need information systems, right, to provide with information, because he or she can do this manipulation where data is transferred to information and knowledge using his or her brain, right? So, so again, some people would argue that the most important goal of information systems is not production of information; it's really production of knowledge, okay, or generation of knowledge. And that's why for a number, I would say like for maybe even decade, at least for the last 20 years, there have been a movement in the field of management and information systems called knowledge management systems. So that's what this movement was about, going one step above information, trying to generate knowledge with the help of technology. But generally, people would say that some people define information systems or argue that the main purpose of information systems is to transform data into information. This is what information systems are all about. So for example, let's say you're working at Walmart, you have data comprised of daily transactions. Then this data is being streamed through the network and saved on a server. And then at the end of each day, you provide output, let's say in the form of a sales report. Then the store manager will look at the sales report and will say something like, okay, it looks like we're selling a lot of milk or a lot of toilet paper, or it looks like we need more dog food, right? So based on that summarized transactional data, the store manager will receive information that will help him or her to make a decision. So here we're trying to define we're trying to define what information systems are, like in a very superficial way, without discussing any of the individual components. But let's talk about some of the elements of this definition. And by the way, this is not the ultimate definition that we'll be using in this course. This is just like an example of one way to explain. I guess it's a practical way to explain what information systems are. So once again, we're trying to define what information systems are. So we already explained what we mean by data and information. So let's talk about systems. Typically, a system is defined as a set of interrelated components that work together towards a particular goal. Systems can be technical and non-technical. For example, systems can be social or biological, right? So what you see here is an example of a biological system. So here we have a respiratory system of a human. So all those components, they work as you well know, they work together towards one particular goal, which is to keep our body, our organism oxygenated, right? To make sure that we have enough oxygen to sustain our living, okay? And also all of those components are important. They're all, interrelated. Like if your nose is blocked, then you have problems getting the air inflow inside your lungs, and if within your lungs there's a damage due to smoking, then you have problems converting air into oxygen and things like that. So all of those components are very important, right? There is, one component influences the other to the point where sometimes we're not aware how one little thing, such as allergy, right, leads to problems breathing, and then to unfortunately more serious health complications. So all those components are interrelated. So this is a biological system. Now here you have an example of a technical system. Here you have a very high-level diagram of the CPU, Central Processing Unit architecture. Typically, CPU is called a processor. As you probably well know, the most common brands of processor is Intel and AMD. Okay, so for a processor, you have registers. So this is where information is stored using binary machine code. Then you have combinational logic. So this combinational logic allows you to manipulate with those registers. So when the data comes in, it's being manipulated, it's being put into registers and manipulated using combinatorial rules or logic. Then you have control unit that maintains operations of all the components of a CPU. You have main memory. Typically it's called cache. So this is where some intermediate results are being stored. So the data can be from the input can be stored in the main memory. Then it can go into the registers. This is where manipulation is done. Then it's temporarily stored in the main memory again. And then at some point, the CPU generates output. What is the result of that computation? So this is an example of a technical system, and all those components work together. Now, in relation to this concept of a system, which I think is pretty clear what it is, there's also something called system thinking. I mean, this concept has been around for decades. I think it was born in engineering when organizational psychology started to look at certain engineering phenomena. And system thinking is also important to the information systems field, although I would argue it's important in all facets of life. So what is system thinking? It's briefly I would say that it's a holistic perspective on complex phenomena. System thinking forces you to view complex phenomena as a combination of components and their interrelationships, as opposed to oversimplifying things by concentrating on individual components. Okay. So this distinction requires some explanation, so hopefully I'll be able to give you a practical illustration of what I mean by lack of system thinking. You see, humans, they like to oversimplify things. I think that's something related to our human psychology. We like simple ideas and simple solutions, right? For example, if you feel sick, God forbid, then when you go to a doctor, I think most people want to hear something simple, like a simple advice. Take that pill and all of your problems will go away, right? What people don't want to hear is that your body is a very complex socio-psychological system, and everything that you do in your life, every component that you have in your body determines your health, right? So you cannot, sometimes you cannot tackle the general complex problem of poor health by concentrating on just one component, okay? And that's what people don't like to hear from doctors and I think doctors also understand if they give this kind of advice, they're not going to make much money, right? Because if you keep telling somebody, like whenever somebody comes to you and you say something like, okay, you're not feeling well, watch your diet, start exercising, make sure you do something that makes you happy, so that the psychological part of your system, is well maintained. Those seems like too simple. Nobody wants to pay money for that, right? What we want to pay money for is like some kind of silver bullet, some kind of magical pill that will solve our problems, right? So yeah, humans don't like this complexity. They want something simple, and they tend to oversimplify things. So one example of lack of system thinking is this whole focus on vitamins. And up to this date, you see all those infomercials on TV. You see those commercials on YouTube, social media about like different vitamins, different supplements that will make you healthy and happy with just like one single shot. Let's take vitamin C for example, right? For a number of years, people would say, well, if you consume vitamin C, if you buy a supplement, you will be in good health. It will strengthen your immune system. It will make you a very healthy and happy person. Well, for a number of years, scientists have been saying, well, it doesn't work like that, right? Vitamin C is just one little thing, is like one little component of your overall organism, right? So what they're saying in relation to vitamin C specifically is that lack of vitamin C will give you serious problems, right? However, simply by taking vitamin C, you're not going to improve your health, you're not going to improve your immune system, okay? So it's like a very simple component, very small component of your entire body, right? And you cannot just bring down the issue of health and immunity, immune system just to vitamin C, okay? But again, people don't like to listen to those complicated arguments. They like something simple. Okay, buy this vitamin and you'll do great, right? This phenomena, this tendency of humans to concentrate on one single factor is exploited in all kinds of advertising campaign. Something along the lines, chew this gum and everybody will like you, you will have a lot of friends. Now, maybe chewing gum will help you with your breath a little bit, but it's not going to make you popular among other people, right? So you cannot just you cannot formulate somebody's social problems such as loneliness in terms of chewing gum, right? But that's what everybody's trying to do. They're trying to ignore the overall system and just concentrate on one factor. Sometimes it works. For example, when you come to a mechanic, let's say your car wouldn't start, so they just focus on one component. Let's say your battery, they change it, and then your car can start again, and you can drive your car to work. So sometimes it works for simple systems such as a car, because I think a human organism is infinitely more complex than a car. But most of the time, when you're dealing with really complex systems with millions of interrelated components, then it doesn't work that way. You cannot just solve problems by looking at one component of a system in isolation from all other components. So this is what system thinking is. One earlier mentions of system thinking that I saw was an engineering textbook. It was kind of funny how they discussed it. They were talking about building bridges in that engineering textbook, and what they said that when managers, engineers, when they build bridges, they concentrate on blueprints, but they never pay attention to people who actually execute those blueprints. And they give an example of one construction crew that unfortunately had problems with alcohol consumption. So every day after work, they would drink a lot, and that would impact their well-being and decision-making next morning, right? So because of that, they made a lot of mistakes in the process of pouring concrete, and the bridge pillars of foundation had a lot of cracks, and it actually led to the bridge collapsing. And I think unfortunately there were some victims because of that accident, right? So that's what they were trying to say. When you build bridges, don't just concentrate on the blueprint. Also take into account the people who are executing that blueprint. Okay, so that's the earliest example of system thinking that I saw, and it came from the field of engineering. So having defined information and system thinking, now let's discuss the overreaching, the most important definition of information system that we'll have in this lesson. So here we define information systems as complex socio-technical systems. By socio-technical, we mean that those systems have technical components such as software, hardware, and data, and also non-technical components, right? And those non-technical components include things related to people and organizations within which those people function. So once again, information systems are complex socio-technical systems comprised of hardware, software, data, people, and organizational components that work together to transform data into useful information. So once again, it's information. It doesn't mean that you will become knowledgeable in something if you have access to an information system. Now, some examples of socio-technical systems. One example comes from my own article on the Internet of Things. A lot of times when people discuss Internet of Things, they discuss the technology. They discuss the hardware, the RFID tags, wireless sensors. They discuss the software that is used to power various IoT applications. They discuss cloud storage. They discuss, they focus a lot on the networking aspects of IoT, but they never discuss that broader environment. For example, in order for you to be successful with your IoT-based product, you also need to take care of social issues surrounding your application. For example, you need to persuade consumer privacy groups that you're not violating anyone's privacy with your application. Also, you need to make sure that your application is complying with existing legislation in relation to privacy, in relation to data storage, in relation to wireless communication. Also, developing IoT applications requires entrepreneurs, people who are willing to invest their energies, their expertise to developing new ideas, and also the physical environment. I mean, you cannot ignore the physical environment within which your IoT applications are being implemented. For example, low-frequency RFID tags, they're very good at penetrating objects. For example, they can be used in retail, but the problem that those low-frequency RFID systems have, for tracking items is that they're easily blocked by metal, like for example foil. So if you put some of those RFID tags, they can be effectively blocked with foil. So for example, if RFID tags are used for security purposes in a bookshop, what you can do, you can come with a foil bag, right? And then just put those books in that bag, and you can leave the premise and no alarm will ever sound because it will block the signal coming from those low frequency RFID tags. Now don't do it. Don't get caught stealing something from a store and then telling you that I explained to you in a lecture how to do it. But I'm just saying that physical environment is also important. Social and physical environment is very important for creating successful IoT applications. It's not just about this. It's not about this area. Now, some theories or theoretical perspective that outline socio-technical thinking and also tells you like where it all came from. I forgot the first name of this American organizational psychologist, but his last name is Levitt. At least that's how I pronounce it. So he came up with this framework called Levitt Diamond. So what this framework tells you is that technology is only a small component of an organization. Technology also interrelates with organizational processes, organizational structure, let's say hierarchy, and also people that work in that organization. So if you want to be successful in integrating technology within an organization, you cannot just focus on technology alone. You need to make sure that this technology is compatible with business processes. You need to make sure that people know how to use this technology, and you also need to make sure that technology is well suited for the given organizational structure. I have practical experience implementing certain IT projects as an administrator, and what I noticed, especially for the last 10 years, is that whenever you have an IT project in your hands, technology is often the least problematic component. The areas where you encounter the problems the most are people and organizations, in my opinion, right? So sometimes organizational politics stands in your way. Sometimes people are playing all kinds of games. Sometimes they're not prepared to use your technology. Sometimes they're prepared, but they're trying to sabotage your implementation because they, somehow they view it as an invasion of their turf, of their territory. So that's how they perceive your technology from a political standpoint and not from a technological standpoint, right? And I can give you so many examples of when like two or more items are not aligned. For example, I worked on implementing certain applications in a college of business, and a lot of people were just saying that, well, we don't have knowledge to use it, and that was their answer whenever I asked them to use the system. So I organized some training seminars for them. I actually told them to come to a lab where I would help them together with some IT employees to migrate their data into this new digital measure system. And they give me all kinds of answers, like I'm busy, like I cannot do it, I have too many publications to enter. So eventually I started approaching it from that organizational side. So I started threatening them with action from top management of the university if they don't comply with that, right? So technology was there. We bought digital measures. There were very little technical tweaks that they did for us. The system was available through the cloud. It was never a problem. The problem was always people. Okay. Sometimes, one thing that I experienced in the UAE all the time is that whenever we buy any kind of technology, most of the time it comes somewhere from the West, like United States or Europe, and sometimes it's simply not compatible with current organizational processes that we have in the Middle East, right? So just a very, very tiny thing. Zip codes, right? A lot of software, a lot of websites in the United States and Europe, they require entering zip codes as a part of the workflow. Well, in the United Arab Emirates, at least when I lived there were no zip codes. So that was a big stumbling block for a lot of processes. So processes in the UAE were not compatible with the technology that is coming from the West. Also, sometimes technology, it violates existing organizational hierarchy. I cannot come up with a personal example right now, but there's a famous study that was published in Management Information Systems Quarterly, which is the #1 publication in the field of MIS. It was about implementation of GIS, Geographic Information Systems in India. And that was done for a government department responsible for issuing crop permits to farmers. So basically the goal behind that system was that they didn't want farmers to go bankrupt, to lose their crops, so they asked farmers to apply for a permit every year to grow a particular crop. So they were trying to ensure that farmers make money, they don't lose their crop, because it becomes a big socioeconomic problem if they do. So it was done manually for a number of years, where some people go to the field, they take a note of the soil characteristic or whatever is needed, and then they write their recommendation, and this recommendation goes through several approval levels, and then at the end the head of this department signs off a permit and it's given to a farmer. So one day they decided to implement a geographical information system to streamline it, so that you don't have all those levels of decision making. You just have an agent going to the field, entering all soil parameters, and then the permit is automatically issued or denied, right? So when they did that, the system seemed to be like a very good idea from that operational technological standpoint. but it was a huge failure from the perspective of organizational structure. What happened with the system, it completely eliminated from the decision-making cycle, from decision-making authority, all those levels of top management. Their signature became irrelevant with this new system. So they did everything they could to sabotage the system, and eventually the system failed, right? So this is an example of technology not being compatible with organizational structure. One positive example of technology reinforcing certain processes. Again, when I moved to Abu Dhabi, I had to go to hospitals like to process my visa, to do this and that. And what I've noticed, like one thing that irritates me a lot is when people cut in front of me in a line. You know, you go to a hospital, right? And you usually like to go to a hospital, you take like, I don't know, 2-3 hours away from your work, from your productive hours, and somebody gets in front of you. And, you know, in a way, it's, I don't know what, I'm still trying to understand what it is, like why it makes me feel so upset when somebody cuts in front of me in line, but I felt very upset and irritated. And then I noticed like there was this trend, like within 1 or 2 years, I think it was some kind of government mandate. It was a part of their medical license requirements that everybody had to buy those ticketing system, right? So in other words, when you go to a hospital, you don't just wait in line. You get a ticket and then you wait until you're called, you know, based on the number of your ticket. Now, people still cut in front without any tickets sometimes, but it eliminated a lot of frustration that I had when I clearly see that somebody was not in the line and they go right in to a particular office without asking anybody, and they pretend that nothing is happening. So with this ticketing system, I think things became much more pleasant. Even if somebody cuts in front of me, I kind of, you know, have my ticket. I know when it's going to be my turn. So I'm sitting working on something or drinking coffee, waiting for my turn. So sometimes technology reinforces processes. And obviously, technology has certain processes embedded as well. So it's a mutual relationship back and forth. So overall, all those components are mutually dependent. They all influence each other in this Levitz diagram. Now, another theory that is quite popular up to this date is the so-called actor network theory by Bruno Latour. I think it's it's a very important theory because it gives you an important, a valuable perspective on how to look at technology and how to understand certain phenomena in relation to technology. So again, there are many books written using actor network theory. Bruno Latour himself wrote several books trying to formulate his theory. But it basically comes down to that. It's not a theory, it's more like a framework or method for analyzing technologies and related issues. So what this theory says is that technologies can be best understood by mapping various technological and non-technological actors within a network. So any technology that you use is connected to other actors, and those actors can be anything or anybody. They can be human actors, they can be physical actors like a house. So here we have a human actor, which is an older person. Here we have a non-human actor, which is environment, neighborhood, home. Then we have other human actors. So it's only when you visualize this complex network of human and non-human actors that influence each other, this is when you will start to understand better what's happening with technology. Again, I think a lot of IT entrepreneurs, they have this technology focus. They think that if you build a great product, then clients will come. Well, sometimes it's not about product. It's not about the technical actors. Sometimes it's about non-technical actors, right? For example, if you look at the history of Microsoft Corporation, there were a number of non-human actors that influenced the development of the company in a positive way. For one, as far as I can recall, Bill Gates' mother, she was on the board of IBM, right? So that helped them to sign this contract with IBM, writing this first operating system for IBM PC, for IBM PC compatible desktops. It was called MS-DOS, right? So that was like a human actor that gave a big push to their organization. Another thing that was happening at that time was that fight between IBM and Apple. Apple was focusing on personal computers. IBM, at that time, when in the early days of Apple, they were not focusing on personal computers. They were looking at corporate clients as their most lucrative source of revenues. But then they realized that they were wrong, that they missed a very important market. So they decided to catch up with Apple. And as a part of that catch-up strategy, they decided to release that operating system that would make it easier for other vendors to build computers with that operating system to create hardware components that would also compete with Apple architecture. So there were like a number of things happening that helped Microsoft to become successful. Not just the fact that they had a good product. In fact, some people argue that their product was quite bad, compared to other operating systems. But nevertheless, those human actors supported the development of the company. So this is just like one brief example of how to use actor network theory for analyzing issues surrounding a particular technology. Now, towards the end, we'll try to explain the difference between computer information systems and management information systems. As I explained before, computer information systems as a field, as a profession, as a major is very broad. It draws on 3 pillars of knowledge. So CS majors are typically equipped with knowledge in technology, business, data. Also, CS programs have a heavy emphasis on developing soft skills related to leadership, teamwork, communication, and personal integrity. So this is like a brief way of explaining what computer information systems are. Now, to be honest with you, sometimes I don't see any difference between computer information systems and management information systems programs. They almost have identical coursework. But if I were to explain like what's the difference, I would say that maybe computer information systems have a larger focus on technical subjects, while management information systems programs, they have more focus on business subjects. And those business subjects are covered with the intention of either specifically focusing on how to manage information systems, right? How to, management of information systems. In other words, to equip students with knowledge on how to manage information systems and various components of information systems, or on information systems used by managers. So this is where that management keyword kind of comes into play. This is the distinction. But all in all, sometimes I don't see much, as I said, I don't see much difference between CIS and MIS programs. Now here we will try to look at some examples of computer information systems, management information systems, and a related concept, enterprise systems. So what you see here is a very high-level sketch of the modules that comprise the so-called Enterprise Resource Planning System, or ERP. SAP is by far the most commonly used enterprise information system, especially when it comes to manufacturing, oil companies, energy companies, and things like that. So an ERP system is comprised of a number of modules, of subsystems like customer service, management system, procurement management system, human resource management system, and things like that. So each of those systems can be viewed as an example of management information systems, because they're used by management to manage a particular aspect of operations. For example, human resource management systems are used by human resource managers to manage their human resources, right? So that's an example of a management system. Now, the overall system is called Enterprise Resource Planning System. This is an important keyword, enterprise. What it tells you it's beyond management. Everybody uses this system to execute his or her processes or tasks. When I was a doctoral student at the University of Houston, one of my research projects was actually following implementation of PeopleSoft, which was a very popular ERP system at that time for universities at the University of Houston. And this system was very complex. I think they spent 10 years and millions of dollars implementing it. But when they were done, every aspect of the university's operations was automated through PeopleSoft. Sometimes it was scary, like you do one thing, and you think that nobody will notice, but then whatever you do cascades through the entire system. For example, you go to a library as a student, you scan some books, you check out some books. Now all those books are automatically added to your library record in the system. Then if those books are overdue, this library system automatically starts billing your student account with fines. As long as you bring the books back, they will remove all those fines. So everything was done through the system and everything was interconnected. So that would be an enterprise system, right? When we're talking about a management system, it's something that is used by managers, right? And when we say computer information systems, I would say we mean the same thing as management information system, but we're just saying that we're talking about the computing component of that management information system. So when we talk about the CRM system, we're talking about the data, the servers, the software that is being used, and we're not talking about management, meaning the people who are using that system. So those are some examples of various types of enterprise systems, MIS systems, and CIS systems being used in the workplace today.